Hey, you guys, we're going to start going over some of the stuff you took home to do for work. We're going to look at week 1. And I'm just going to go over some of those problems in that first week of work and give you some examples so that if you had any questions, you might be wondering what did you need to do with all that stuff. Okay, hopefully you've been working on them every day, and some of you guys have been sending that stuff to me, and I'm keeping up with grading it so that we have a record of all that, and I know who to call and who to give some extra help to. Let me just show you what I'm doing here. All right, so this is the week 1 math, March 16th to the 20th, and we're going to go over some of your work. All right, so you have this paper right here to kind of keep you on track of what you're doing, and hopefully today you're somewhere down here because it's Tuesday, the 24th. And so as you guys send me in your work, I'm keeping track of how you're doing by grading each of the questions and marking them on this sheet. And so in week 1, you will have done all of these assignments. All right, and so we're going to go over some of those and make sure you know what you're doing. All right. So I think everybody knows how to do this page. This was a review of multiplying by powers of 10. And remembering what those powers of 10 means, you could use that place value chart up at the top. So for example, 3 times 10 to the 6th power on number 2, you would have said, oh, that's like 3 times 10 with 6 zeros on it. Or 3 times 1 with 6 zeros. And then put in your commas and you would have gotten 3 million. 9 times 10 to the 2nd power, you know that's like 9 times 100, so you're thinking 9 times 1 is 9. And then we know we're going to annex 2 zeros on that and get 900. Okay, on using a pattern, this was more of the same thing, except using a pattern to multiply by multiples of 10, 100, and 1,000. This was the same sort of thing, except you look at the patterns and how they changed as you multiply by a larger exponent of 10. All right, so you started out with the basic fact of 9 times 2. And then every time you multiplied it by a power of 10, you knew you annexed a 0. So 180, 9 times 2, 18 times 10 to the 2nd, you're going to annex 2 zeros. 9 times 2 is 18 times 10 to the 3rd, annex 3 zeros. 9 times 2 is 18 times 10 to the 4th, you're going to annex 4 zeros. And that's the pattern that we followed with those multiplication facts. All right, I don't think anybody would have had any problems with that. All right, so this color by answer the adjacent place value, that was tripping up a few people, and I just want to remind you of what we were doing on this in class. So when it's asking us which number has a 7 in it, if it's 1/10 the value of the 7 in this given number, we are remembering that our place value positions increase 10 times as you get larger and decrease 10 times as you get smaller. So remembering that when we get smaller, dividing by 10 is the same as 10 times smaller. Okay, and we also know that means times by 1/10. So all of these 3 things mean the same thing. All right, so what do we use to help us find the answer to this if we are confused? Well, we use that quick place value chart. All right, I love that thing. It's the newbie math student's best friend. So you put your decimal point, and you all remember this. All right, and I'm filling in my place value positions: 1s, 10s, 100s, 1/10, 100th, 1/1000. And so when I'm looking at this number, 796 and 31 hundredths, and I'm looking at that 7, I'm asking myself, all right, that's 700. How am I going to make that 10 times smaller, or find a number that is 1/10 of the 7 in the hundreds place? Well, I know if I'm going to get smaller that I'm not going to move over to the thousands place. I'm going to have to move over to the hundreds place. So I know that I'm looking for a number that has a 7 in the tens place. So I look at my answer choices, and I see that this first one has a 7 in the hundreds place, so that can't be it. The second choice has a 7 in the tens place. So yes, that 7 has a value that is 1/10 the size of the 7 in that first number. So I know that this is going to be my answer choice. I'm going to go ahead and look at this one, and I see that's a 7 in the thousands place. So that would have been 10 times larger, not 1/10 the size of the 7 that was in our given number. All right, so let's take a look at one that is 10 times larger. All right, if you look at number 4, which number has a 2 in it that is 10 times the value of the 2 in 529,381 and 7/10? Okay, again, I can see my 2 is in what place value position? Well, I can increase my place value chart. Ones, tens, hundreds, thousands, 10,000s, 100,000s, and I can put my number in there. Well, I've got 529,000, 381, and 7/10. All right, so I'm looking for a number that has a 2 that is 10 times larger than the 2 in this number. Well, this 2 is in the 10,000s place. So to make it 10 times larger, that means I would have to find a number that has a 2 in the 100,000s place. So that 2 would have to move over here. I need to find a number that has a 2 in the 100,000s place. So I'm looking over at my choices. This has a 2 in the 10,000s place, so this is not it. This has a 2 in the 100,000s place. Ones, tens, hundreds, thousands, 10,000s, 100,000s. Well, that's what I'm looking for, because it has to be 10 times larger than the 2 that was in my original number in 10,000s. I'm going to go ahead and look at this last choice, and it's 326 and 87 thousandths. Well, that 6 is in the ones place, so that's definitely not 10 times larger than this 2 in the 10,000s place. All right, so using a quick place value chart can help you determine whether you are finding a number that is 10 times smaller, which is 1/10 of the value, or 10 times larger. All right, that's not so bad. All right, so this one, multiplying by multi-digit numbers, this is practicing that standard algorithm. And we use that turtle head method, which is the same thing as old school multiplying. We just stick a turtle's head around it. And it's guiding us through each step. And so they give us some examples here that guide you through the steps. And as you can see, careful alignment of those place value positions when you add your 2 partial products is critical. And then we don't want to forget that on that second step we put in a 0. It asks us to estimate first. So what do you have to do when you estimate? Well, you're going to round it to the greatest place value position. That's one way, so let's do that. I'm going to round 387 to 400. And then I'm going to round 29 to 30. And I can do mental math here because we are mental math experts. I'm going to say 3 times 4 is 12. And then I'm going to count my zeros, 1, 2, 3, and I'm going to annex those zeros. This tells me that my answer that I get when I find my exact answer should be somewhere close to 12,000, and that would be reasonable. Okay, so I'm going to put a turtle head around this just because I don't like turtles. And then I'm going to step this out. I know that 9 times 7 is 63. I know 9 times 8 is 72. Plus 6 more, 72, 73, 74, 75, 76, 77, 78. I know 9 times 3 is 27. Plus 3 more is 28, 29, 30, 31, 32, 33, 34. All right, now I'm going to come down, I'm going to put a 0. Now I'm ready to multiply by my 2 that's in the tens place, which is exactly why I dropped that 0 down there. All right, so 2 times 7 is 14. 2 times 8 is 16. Plus 1 more is 17. Carry my 1, put down that 7. I know 2 times 3 is 6. Plus 1 is 7. I'm going to add up my 2 partial products. 8, 9, 10, 11, 12. All right, I'm going to have 7 plus 4 is 11, plus 1 is 12. 7 plus 3 is 10, plus 1 is 11. I'm going to put in my comma, and yes, that looks like it's pretty close to 12,000, and it's reasonable. Okay, on that next assignment, you are practicing more of that multi-digit multiplication. Some of these numbers get quite big, and so I am looking at 5, 6, and 7. If you get your answers on those, you want to check them with a calculator. Go ahead and do that. All right, so you're going to multiply each of these using the standard algorithm or that turtle head method. All right, so I'm going to pick number 2. And we're going to step out each step. So we're going to say 1 times 9 is 9, 1 times 7 is 7, 1 times 1 is 1, and 1 times 6 is 6. I love it when there's no carrying. I'm going to come down and I'm going to put a 0. Now I'm ready to multiply by the 5 in the tens place. 5 times 9 is 45. 5 times 7 is 35, 36, 37, 38, 39. 5 times 1 is 5, 6, 7, 8. And then 5 times 6 is 30. Then I have to add my 2 partial products. 7 and 5 is 12. Carry 1. 9, 10, 11. 8 plus 1 is 9, plus 5, plus 6 is 15. 1 plus 0 is 1, and then 3. And I forgot to estimate. I'm going to do that now. I know 6,178 is about 6,000. 51 is about 50. I'm going to use my mental math. 6 times 5 is 30. Annex my zeros. 1, 2, 3, 4. 1, 2, 3, 4. So I know my answer should be about 300,000. Now I've got 315,129. And yes, that is reasonable. That makes sense. All right, and you're going to do that multiplication down here also. And you may check it with a calculator if you'd like to. You can check all of these with a calculator. Just make sure you show your work. On number 8, you were doing the area model. 2,346 has been expanded. And then you're going to multiply to get each partial product and then total it up to get your product. Okay, on to the next page. Okay, so this is the color